So, good morning all. On behalf of Speed Team, I welcome you all for this 2020 NEET chemistry question paper discussion. Okay. So, compared to previous years, this year question paper is little bit easy, particularly in chemistry part. So, out of 45 questions, more than 10 questions I think are very easy questions only. All questions are direct questions, either taken from the 11th and 12th chemistry book only. Okay, so if you know the concept and or if you know the formulas, you can easily substitute the things, means you get the answer very correctly. Okay, so let's start. We will see one by one the question paper questions, okay, in this session. So, the first question is sucrose on hydrolysis gives alpha D glucose and beta D glucose, okay. And then second one, alpha D glucose and beta D fructose, and then alpha D fructose and beta D fructose and beta D glucose and alpha D glucose. So, this question is from the biomolecules chapter. Okay, and then in biomolecules, particularly this question is from carbohydrates. So, this sucrose is the disaccharide. Okay, so two monomeric units combined together. This is disaccharide. So, two sugar units, two monomeric units. Okay, so two monomeric units combined together here. So, sucrose is a disaccharide. It consists of two monomeric units. So, the question is, what are the two monomeric units? So, these two monomeric units are combined together by glycosidic bond. So, this is the special type of bond present only in the carbohydrate. Okay. So, we already discussed in the classes. So, here this sucrose, the beta 1,2 glycosidic linkage is present. Okay, so here, so the aldehyde part, CHO part in glucose, and then the C double bond O part, that is ketone group in fructose, are involved in the bond formation. These two things are involved in the bond formation. So that only sucrose is considered as the non-reducing sugar. Okay, so this one is called as non-reducing sugar. So, this is also one of the peculiar property for this sucrose. All disaccharides are reducing, but sucrose is non-reducing. Okay. So, now let us see which monomeric units are present in this sucrose. Okay. I think the option is alpha D glucose and beta D fructose. The B option is the correct one. Okay. So, due to the presence of this beta only, so you get the linkage beta 1,2 glycosidic linkage. Okay. So, this is the structure of sucrose. Okay. So, enzymatic hydrolysis. So, the bond broken here. Okay. So, this is the glycosidic bond beta 1,2 glycosidic linkage. Okay. You get two monomeric units. The one is glucose. The glucose is alpha D. And then fructose is beta D. Okay, so this is the question. And then this is the glycosidic linkage, alpha beta 1,2 glycosidic linkage. So these two things combine together to form sucrose. So this is the structure of sucrose. So sucrose is rich in cane sugar. So that sugar is called as table sugar, cane sugar. Okay. And then second question, elimination reaction of 2-bromopentane to form pen-2-ene. Okay. So this question is the combined question from the chapter haloalkane and haloarene. Haloalkane and haloarene. So this is from the 12th grade, and then pen 2, that is hydrocarbon Then next hydrocarbon. So this hydrocarbon is 11th standard portion. Okay, so hydrocarbon and haloalkane and haloarine. Particularly this question 2 bromopentane is the haloalkane part, and hydrocarbon. So this pentene, so ene. So this is from the alkene part. Okay, so elimination reaction of 2 bromopentane to form pen-2-ene is. Okay, so your question is beta elimination reaction. It follows Zaitsev rule, and dehydrohalogenation reaction and dehydration reaction. So the options are these are all the 4 options, but you have to choose 3 options from this options given. Okay. So this is your option A, C, D, B, C, D, A, B, D and A, B, C. I think so the order are correctly given here. So that is the beta elimination reaction is the first one, and then follows Zaitsev rule and dehydrohalogenation reaction. Okay. So in beta carbon, so the elimination occur, the second carbon, and then so 2 products are formed here. So one is dominant and another one is major and another one is minor. That is, one is stable and another one is stable. The Zaitsev rule only determine which one is the major product, that is the stable product. Okay, and then followed by the dehydrohalogenation reaction, you get this pen-2-ene. Okay, so I think A, B, C, the 4th option is the correct answer. And then this is the reaction. Here this is the first carbon atom and this is the second carbon atom. I already explained the second carbon atom, the bromine is removed, alpha and beta. So this is alpha and this one is alpha and this one is beta. So beta elimination occur. Here 2 products are formed, that is major and minor. So this is major and this is minor. Okay, so this will determine by that Zaitsev rules, and then removal of this hydrogen from this one, and then this Br, beta elimination occur. Okay, you get the product pen-2-ene and pen-1-ene. I think this is 80% and this is 20%. So according to the Zaitsev rule, this one is stable one. Okay, so that is stable and that is unstable. So that only this stable product is the major product. Okay, and then Zaitsev rule is an empirical rule for predicting the favored alkene product in elimination reaction. Mostly, so the stable major product is determined by the Zaitsev's rules. Okay, stable and major product. And then in this G1 code, the 93rd question is the number of Faradays, okay, F, required to produce 20 gram of calcium from molten form of calcium chloride. Okay, so here the atomic mass is given, that is 40 gram per mole. So the options are 2, 3, 4, 1. So this question is from electrochemistry chapter. So this is also very simple calculation. Okay, so the answer is 1 Faraday. Okay, so the balance reaction will, so this is the charge on calcium in calcium chloride. So here calcium is 1 and chloride is 2, chlorine is 2. So Ca plus 2Cl is equal to 0. Cl always has minus because it accepts 1 electron from the cations. So Cl minus always carries minus 1 monovalent cation. Okay, so that is C, you substitute that minus 1 in this step. Okay, calcium plus 2 minus 1 is equal to 0. So calcium is equal to 2. That is the charge, that is calcium 2 plus. So this is cation here. So the oxidation number as well as the valency is 2. So number of required moles means, so this is the formula, mass per molar mass. So here the molar mass is given, that is 40 gram, and required mass is also given in your question paper, that is 20 gram. So now you substitute in the mass place 20 and this place 40, and then you have to cancel 0, 0. Okay, and then 2 by 4. So cancel again, both are the multiples of 2, 1 by 2. So the 1 by 2 is nothing but 0.5 mole. So electricity required to produce 1 mole of calcium. Okay, so that is equal to 2 Faraday. So the electricity required to produce 0.5 mole. So very simple. So you have to multiply these two things. You get the answer 1 Faraday. Okay, so the correct option is 1 Faraday is the correct answer. And then 94th question. So this is from solid state, 12th standard solid state. So in cubic system, so we already studied 3 different types of cubic system: simple, face centered, and body centered. Body centered cube, face centered cube. So shortly called as FCC and BCC. So the question is from this body centered cube. An element has a body centered cubic structure, that is BCC, with a cell edge. Cell edge is given here. So you have to easily calculate this atomic radius. Okay, I think the option is 2 option is correct. I will explain the step how to calculate this one. So this is the diagram, face centered diagram. So here 2 atoms are present in face centered cubic system. Okay, so this is the formula, h square plus 2 into h square is equal to 4 into radius the whole square. Okay, so here this is 1. So I have to multiply these two things. So 3h square and then 4 radius square. Okay, and then 3h square. So I have, so h is equal to, so this is, you write, so h square. So I have to carry over number first. So 4 radius is divided by 3. So this is in square. So now you calculate h. Okay, so the number will be 4 into radius. So this is 3, you write it in 3, and then now, so 4 into radius, 4 root 3 radius divided by 3. Okay, so this 4 root 3 radius divided by 3 is the correct answer. And then 95th question, HCl was passed through a solution of calcium chloride, magnesium chloride and sodium chloride. So this is from S block. Which of the following compounds crystallizes? So this is also again combined chapter, that is chemical bonding and a chemical equilibrium chapter, and then S block and everything. So here the correct option is the sodium chloride is the correct option because this is the ionic product. So this is ionic. Okay, only NaCl is the correct one, I think. So the answer is here you take the solubility product and ionic product both. So the precipitate formation will take place only when the value of ionic product of a compound exceeds its solubility product. So that only I explained previously, that is the combination of both ionic product and as well as the solubility product. Okay, the solubility product constant of NaCl. So, maximum solubility of NaCl in water at 25 degrees Celsius, almost room temperature, is 357 milligram per ml. Okay, so NaCl is unusual in that its stability does not increase appreciably with temperature. Okay, so at 25 degrees Celsius only. So if you have to increase the temperature, the solubility doesn't change. Okay, since at 100 degrees Celsius, the solubility is 384 milligram per ml. So the solubility of NaCl in water is decreased by adding HCl. Okay, so this is the question. So it's almost insoluble in concentrated HCl. Okay, so it will crystallize or it will precipitate. Okay, and the 96th question. So find out the solubility of nickel hydroxide NiOH twice in 0.1 m NaOH. So this is from mole concept. Given that the ionic product of, so ionic product is given here, NiOH twice is 2 into 10 to the power of minus 15. So the four options are: the first option 2 into 10 to the power of minus 8 m, second one 1 into 10 to the power of minus 13 m, and third one 1 into 10 to the power of 8 m, and fourth one 2 into 10 to the power of minus 13 m. Okay, so the answer is 2 into 10 to the power of minus 13 m is the correct answer. So this is the calculation step. So NiOH twice, so this is the solid. So it will become Ni2 plus ion, nickel ion. So this is nickel ion. So this is the cation, so nickel cation. And then this one is hydroxide anion. So this is hydroxide anion. So ionic product, so Ni2 plus and OH minus twice. Okay, so 2. And then let molar solubility of Na2 plus B, okay, so into M. So the concentration of OH minus is equal to 2x in plus 0.1 m. Okay, so now, so 2 into 10 to the power of minus 15 is equal to x into 2x plus 0.1 the whole square. Here x is very small compared to 0.1 molarity. So we ignore this 2x part. Okay, so you only consider this one. So you have to add this one. So 2 into 10 to the power of 15 is equal to 0.01x. Okay, you consider this 0.1 square, and then x is equal to now 2 into 10 to the power of minus 13. So you have to divide. So here this is in multiplication, go that side. So this is in division. So here this 0.01 is there, no? So that is you have to plus 2. So minus 15 plus 2. So the power will be minus 13. So that only I put 2 into 10 to the power of minus 13 m. So this answer is the correct answer. The 97th question. So for the reaction 2ClG gives Cl2G. So this is also in gaseous form, and this chloride is also in the gaseous form. So the correct option is, so this is from thermochemistry lesson. Okay, so del HR is always greater than 0, that is positive. So here this del RS is less than 0. Okay, so here this is the negative value. So the second option is, so this one is negative and this one is positive, and then here this is negative and this is negative, and this one is positive and this one is both are positive. So in this case both are positive. So this case is both are positive and this one is both are negative. So the first two options are, one is positive and one is negative. Okay, here this is negative and this is positive. I think both are negative is the correct answer. So this del RH is less than 0 and del RS is less than 0 is the correct answer. Okay, because it forms the bond. Okay, so the covalent bond is formed in this case, 2 Cl combined together. So which type of bond is formed? Covalent bond is formed. Okay, so del H and del S are negative here, so that only the third option is the correct one. Okay, so the reason behind this one is the given reaction represents the formation of chlorine molecule from chlorine atoms. Here the type of bond formed here is covalent bond. So that's the answer. So del H is negative and as well as del S is also negative here. Okay, so this spontaneity is decreased, so del S is also negative for the given reaction. And the 98th question. So this is from coordination chemistry. I think this is the 12th chapter, coordination chemistry. So 2-3 questions are from this coordination chemistry this year. Okay, here some ligands are given. SCN, F minus, CN minus, C2O4, 2 minus and everything. So which of the following is the correct order of increasing field strength? Okay, so we already discussed in class. So two different types of field, that is weak field and strong field ligands. Okay, so weak field and strong field ligands. So the mostly chloride, fluoride and everything are the weak field, and then cyanide is the strong field ligands. Here 4 ligands are given, you have to arrange. Okay, so increasing field strength order. I think here also this one, 4th option is the correct, because this CN minus is the strong ligand. So these two options are abruptly wrong. Okay, so these two options, because the strong ligand, the example is Cn minus. So from these two options you have to choose. But here the order is confused here. The SCN is less or weak ligand compared to this F minus. Okay, so I think the 4th option is the correct one. Okay, so this is from based on the crystal field theory. You study 2 different types of theory, that is crystal field theory and BSEEPR theory in coordination chemistry. BSEEPR theory you studied in chemical bonding also. Okay, the CFT theory is shortly called as crystal field theory, is shortly called as CFT. So this is mainly due to the presence of D and F orbitals. Okay, so for example you take the D orbitals. So here DD transition and color formation occur due to this one. So the D orbitals are split into 2 types. Okay, so this is in lower energy and 3 orbitals out of 5, 2 are in lower energy level and another one is in higher energy level. Okay, so based on this, so you have to arrange the ligands in order like this. So here Cn minus, the last one is CO, carbonyl. So this is carbonyl ligand. So carbonyl ligand, and this is cyanide in your question paper. So this cyanide and then F minus and then Sc minus are given. So you write the order, 4th order is the correct one. Okay, and then 99 question. So the calculated spin only magnetic moment of Cr2 plus, again this is also from the coordination chemistry. So here you have to know the atomic structure and electronic configuration of this chromium first, and then you have to remove 2 electrons from that chromium. Okay, and then you have to calculate this spin only magnetic moment by using the formula. I think here the correct answer is 4.90 Bohr magneton is the correct answer, because here the okay, so lone pair of electron present in this Cr2 plus is 4. So you have to substitute this 4. See, this is 3d5. So this is most stable due to the half filled orbitals. Okay, so this is most stable in ground state, that is Cr, because 5d. So all orbitals having only one electron like this. So half filled d orbitals. Okay, so this is half filled d orbitals. So already only one electron in the s orbital. So I have to remove 2 electron from this one. So 3d5 become 3d3. Already here one electron is present. So you have to add these two things. So that only I write here the lone pair of electrons in this electronic configuration of chromium 2 plus ion is 4. So now you substitute in this formula, that is n into root of n into n plus 1 by 2 formula, you get the answer 4.89 Bohr magneton. Okay. So root of n into n plus 1 by 2 formula. So you substitute 4 plus 1 by 2 . So n into n plus 2, n into n plus 2 by 2 formula. Okay, so here 4, 6 divided by 2. And then which of the following set of molecules will have 0 dipole moment? Okay, so boron trifluoride, hydrogen fluoride, carbon dioxide and 1,3-dichlorobenzene is given. So here this one is dipole moment is equal to 0. That means there is no lone pair of electrons. Okay, no lone pair of electron present in this structure. Okay, so that only you get the dipole moment value 0. I think the third option is the correct one. Boron trifluoride, beryllium difluoride, carbon dioxide and 1,4-dichlorobenzene. Okay, so all electrons are involved in the bond formation. So there is no lone pair of electron in the center atom. Okay, so you concentrate only on the center atom. All electrons are involved in bond formation. So no lone pair of electron in central atom. So that only the dipole moment is equal to 0. So that third option is correct. Okay, so this is the boron trifluoride. So here also boron, all 3 electrons are involved in the bond formation. So there is no lone pair of electron. Okay, so this is mu is equal to 0. And then second one, here beryllium dichloride, here also all are involved in the bond formation, beryllium fluoride and as well as the beryllium chloride. Okay, so no lone pair, mu is equal to 0. And then here also C double bond O and C double bond O, that is carbon dioxide. Okay, all are involved in the bond formation. And this one So 1,4, that is our para, in para position chloride are added. So 1,4 dichlorobenzene. Okay. So all 4 are having the 0 magnetic moment. Okay. And then here water, other example water, so it's given in your choice. So water is having the 2 lone pairs. So these 2 pairs are involved in the bond formation. This is the central atom oxygen. Here it has 2 lone pair of electrons. So definitely it has magnetic moment value. It's not having, mu is not equal to 0. Okay. So other ammonia, it has only 1 lone pair of electron is present in the central atom. So this is mu is not equal to 0. And then here also 2 lone pairs. So due to the presence of the 2 lone pairs, mu is not equal to 0. Okay, here also hydrogen fluoride. So mu is not equal to 0 because 3 lone pairs are present. So 3 lone pairs. And then the following metal ion activates many enzymes, participates in the oxidation of glucose to produce ATP. Okay, so this and all you studied in your biology paper and zoology paper, and with Na. So it's responsible for the transmission of nerve signals. So this is from S block element. So this is from the uses of the alkali metals. Okay, so alkali metals. So this is along with sodium. So the correct answer is potassium. So you are very familiar with the sodium potassium pump. So the last year one question is from magnesium part. So this time, so already sodium is given in your question paper. You have to find the other one alkali metal, that is potassium is the correct answer. Okay, so electrolyte sodium. So this is also cation, and potassium, this is also cation. So this is present in the S block, one element. So this is called as alkali metals. Okay, so play a key role in the transfer of nerve impulses. So this is the diagram to explain. So this is the sodium potassium pump. So this is for the proper transmission of signals. Okay, sodium potassium pump. So along with sodium, another one element is present for the effective nerve transmission, means that is potassium is the correct answer. Okay. And then 1 or 2 question number, an alkene on ozonolysis gives methanol. So this is aldehyde. So here IUPAC name is given aldehyde. So this is methanol, that is HCHO. So the common name is formaldehyde. So it has only 1 carbon atom as one of the product. Okay, so you have to choose one alkene. So that alkene on ozonolysis, that is addition of O3, ozone. So your major product will be methanol. Okay, so here 4 options are given. So here one aromatic. So the 4 options are aromatic alkene, okay, so in this, so the double bond is present inside the ring. Here the double bond is present in the aliphatic hydrocarbon part, side chain. So this is ring and this is side chain, and this is also in the ring and this is in the side chain. So I think the first and third options are not the correct. So either you have to choose the option from this one, second one and fourth one. So the most correct option is the fourth one is the, so the double bond is present in side chain is the correct answer. Okay. So this is when ozonolysis reaction produce methanol and ethanol, that is formaldehyde and as well as acetaldehyde. Ethanol is acetaldehyde. So the formula is CH3CHO. So alkene is propene. So the IUPAC name is prop1ene. But here, so the one hydrogen is substituted by cyclohexane. So this is cyclohexane. Or otherwise this structure resembles the propene only. Okay. So CH two double bond CH and CH3. So here the one hydrogen is replaced by this one. Okay. So the correct option is this one. Fourth option is the correct one. And then this question is also from the alkene part. So already one combined question is also from this alkene part. I think the 92nd question. And then 103 question number. So the rate constant for a first order reaction. So this is from chemical kinetics. So this question is from chemical kinetics. So first order reaction is 4.606 into 10 to the power of minus 3 and then per second. So the time required to reduce 2 gram of the reactant to the 0.2 gram. Okay, so here 2 gram, this is in whole number and this is in fraction. So this amount of reactant, so usually we write the reactant in the left hand side and product in the right hand side. So here you take 2 gram of reactant, this is reduced to give 0.2 gram of product. Okay, so here you have to calculate the time required. So express in seconds. Here 200 seconds, 500 seconds, 1000 seconds and 100 seconds are given. I think the correct option is second one. The 500 seconds is the correct answer. So this is the for first order reaction. So this is the formula. K is equal to 2.303 divided by T log R naught divided by RT. Okay, here the rate constant is given in your question paper. 2.03, this is the numerical part only, already in the formula T. So you have to find this T only. Okay, so log 1 by 1 divided by 1 by 10. Okay, so this will, so you have to take this, transpose this T to left hand side and then you take this one from left to right. Okay, so this will become 2.303 divided by 4.06606 into 10 to the power of minus 3. So I have to cancel, you get the answer 500 seconds. And then 104. So the reaction between acetone and methyl magnesium chloride. This methyl magnesium chloride is nothing but Grignard reagent. Okay, so this is Grignard reagent. So followed by hydrolysis will give secondary butyl alcohol, tertiary butyl alcohol, isobutyl alcohol and isopropyl alcohol. Okay, so mostly tertiary alcohols only formed in this reaction. So particularly acetone. Okay, so the correct option is tertiary butyl alcohol. So this question is from carbonyl compounds. So in carbonyl compounds you studied aldehydes, ketones and carboxylic acids. So this question is from ketone. And then this is acetone. And this is Grignard reagent. Okay, so this CH3 C double bond O CH3 group. So this double bond O group is converted into OH and then this R group is go and attached to this one. So you get 3, okay, so here 3 R groups are present. So this is called a tertiary alcohol. So tertiary butyl alcohol is the correct option. Okay, so this is so methyl group. So this is acetone, and then you get 3 methyl group like this. Okay, C you write like this, OH, and then CH3, CH3 and CH3. All 3 R groups are methyl group. So this is tertiary butyl alcohol. Tertiary butyl alcohol. And then 105 question number, which of the following is a natural polymer? Okay, so this is from polymer chemistry. So in polymer chemistry we discussed natural polymers and as well as the artificial polymer, that is the polymers present in the living organisms, and we prepare some polymers in laboratory. So this one is natural polymer. This is also from the artificial polymer only, but it occurs natural from the rubber tree and everything. So polybutadiene styrene, polybutadiene and acrylonitrile. The last option is cis-1,4 polyisoprene. I think this answer is the correct one, cis-1,4 polyisoprene. So this is present in natural rubber. So your question is natural polymer, rubber is the polymer. So this is the monomeric unit. So this is 1,4 polyisoprene is the monomer of this natural rubber. Okay, so this one is the correct. And then cis-1,4 polyisoprene, which is also called isoprene rubber, so major ingredient or major monomer of this natural rubber. So this is the structure, natural rubber. So this is one monomeric unit, second monomeric unit and third monomeric unit. So the polymerization reaction occurs here. Polymerization reaction. The reaction type is polymerization. So natural rubber is the polymer. And then this is 1,4 cis-1,4 polyisoprene. So here, so you take this CC, the CH2 is present like this. So this is cis. So you number start from this one, 1, 2, 3, 4. Okay, so that only, so the linkage is formed either in the first carbon atom and the fourth carbon atom. So that only this is called cis-1,4 polyisoprene. Okay. So identify the correct statements from the following. Okay, so this is also from the P block elements. So particularly 14th group, carbon family. So 14th group, carbon family. Okay, so carbon dioxide is used as refrigerant for ice cream and frozen food. I think this is wrong statement. So your question is pick the correct statement. So the structure of C60 contains 12 6 carbon rings and 25 carbon. So you read like this. So most of the students misunderstood this part. So 25 carbon rings. Okay. So not 25 carbon rings, 25 carbon rings and then 12 6. Okay. So 12 6 carbon rings. Okay, I think this is also wrong because 12 5 carbon rings and 26 carbon rings. So this is given in reverse. So this answer is also wrong. And then ZSM5, a type of zeolite, is used to convert alcohols into gasoline, and this is correct. So it acts as the catalyst for lower hydrocarbons. So this is for using lower hydrocarbons, okay. And then CO is colorless odorless gas. This is obviously correct one. So I think C and D are correct. Yes, A and C only, B and C only, C and D only. I think this one is correct. A, B and C only. So this is the correct one, C and D. Okay, so ethanol, methanol and larger alcohols can be converted into gasoline. So at 300 to 400 degrees Celsius in the presence of zeolite catalyst. Okay, so this is the correct statement. And carbon monoxide is a colorless, odorless, tasteless, flammable gas that is slightly less dense than air. Okay, so this is also correct. So in your question, colorless, odorless gas is given. Okay, and then other two options are wrong. So it's toxic to animals that use hemoglobin as oxygen carrier. So both invertebrate and vertebrate. And then third one, the first option, carbon dioxide, is usually called dry ice. That is okay, but is commonly used for refrigeration because of its property. So solid carbon dioxide exhibits a property called sublimation. But in your question paper, so this is clearly given carbon dioxide gas. Okay, so here solid is correct, this one, but here carbon dioxide gas is given, so this option is wrong. Okay, so this is also 12 5 carbon ring and 26 carbon ring is the correct one. Okay, so C60 which contains 12 5 member ring and 26 member ring. So that's the correct. So 107, the correct option for free expansion of an ideal gas under adiabatic condition. So this is from gaseous state. So that is states of matter in 11th standard portion, states of matter. So we studied two states of matter in this chapter, liquids and gaseous state. So this question is from gaseous state. So Q is equal to 0 and del T is lesser than 0 and W is greater than 0. So this is the first option, and then Q is lesser than 0 and then del T is equal to 0 and W is equal to 0, and then Q is greater than 0. Delta T is also greater than 0 and W is also greater than 0. Here all are equal. Okay. So the correct option is the last one. All things are equal to 0. So ideal gas under adiabatic condition. So Q is also equal to 0. The change in temperature also equal to 0 and W part is also equal to 0. So this is for first law of thermodynamics. Energy of universe is always observed, or total energy of an isolated system is always conserved. So the change in energy is equal to Q plus W, wherein del E is equal to, so the total is considered as internal energy. Okay, so del E is equal to internal energy. So this is also again combined chapter from thermodynamics and gaseous state. And Q is equal to heat and W is equal to work. An adiabatic process, heat exchange between system and surrounding is 0. Okay, so Q is equal to 0. So wherein del E is equal to Q plus W. So Q is equal to 0, del E is equal to W. For free expansion, since P extension is equal to 0, so work done is also 0. So the total system is equal to 0. So del T is equal to 0. But the options, other options are very wrong. Okay. So the other option, 3 options are wrong. And then 108. So which of the following oxo acids of sulfur has peroxide link? So this type of link is called as peroxide link. Okay, here 4 different types of sulfur containing acid containing sulfur groups are given. Again, this is also from the P block, that is 16th group, oxygen family. Okay, H2SO4 sulfuric acid, H2S2O8 peroxo disulfuric acid, and pyrosulfuric acid and sulfurous acid. So, this is very easy question from the question itself. So, this name is also given in your question paper. So, very easy question. So, in this name itself you have to easily decide. So, this option is the correct one. Okay. So, this is the correct option. So, in this system only, so the peroxide linkage is present here, peroxy linkage. So, this linkage is called as peroxy linkage. So, the option B has O bond O linkage. So, hence option B is correct. And then 109, identify compound X here. So, from this is toluene. So, you can synthesize this benzaldehyde from toluene. Again, this is also from hydrocarbon and as well as the carbonyl compound. So, you have to synthesize this aldehyde from this hydrocarbon part. So, here halogenation reaction occur in the presence of light. H mu means this is photochemical reaction. So, one intermediate product is formed here. So, you have to pick which one is the intermediate product. Okay. So, the first compound CH2Cl is formed, but here only the required thing formed here is CH, but in this option CH2 is present. So, this is wrong, and then here CH. Good. So, this option is the correct one and other thing CH is missing. So, I think, so this is you have to answer lateral thinking only. Okay. So, this option is the correct one. Okay, so this is toluene in the presence of chlorine. So, chlorination occur in the presence of light. So, this CH3 becomes CHCl2. Okay, and then third one, addition of water. So, this oxygen go unattached to this one, and then this H2Cl2 combines to form HCl. So, how many molecules? 2 molecules of HCl. Okay. And then 110. So, this is from atomic structure, chapter atomic structure. So, this is also very easy question. So, this and all you studied in your 9th and 10th grade itself. So, the number of protons, this is nothing but atomic number, neutrons, the mass number, number of protons and neutrons, and electrons. Okay, so in respectively are. So, here, so 17,104 and 71 is given, I think this is Li. So, lutetium is given, I think. So, here lutetium, that is 71 and 104. Okay, so this is the number of protons. And then 104 you have to minus this one. So, neutron. Okay. So, the and electrons are respectively. So, 71 and 104 and 71 is the correct answer. Okay. So, number of protons is equal to atomic number of the element, and number of electrons, number of protons is equal to number of protons. Okay, so number of neutrons is equal to mass number minus atomic number. Okay, so this is usually represents, so this is the symbol of atom or element. So, this one is element. So, this is mass number that is the sum of proton plus neutron, and this is atomic number. So, only proton. Okay, so the number of protons is equal to number of electrons. And then identify the incorrect statement. So here this question is from D and F block elements, I think. So D and F block. So this time also more questions from this periodic table. So the transition metals and their compounds are known for their catalytic activity due to their ability to adopt multiple oxidation states and to form complexes. Okay, so that only coordination complexes are formed from D block elements. So coordination complex, that is nickel, chromium, okay, so manganese, iron, platinum, these things are involved in the formation of this coordination complex. So you have to pick the incorrect statement. This statement is correct. And interstitial compounds are those that are formed when small atoms like hydrogen, carbon and nitrogen are trapped inside the crystal lattices of metals. So I think this is also correct. And then third one, the oxidation state of chromium in CrO4 2- and Cr2O7 2- are not same, but this is incorrect statement. So the oxidation number, so you do this sum, Cr O4 2- is equal to, so you have to compare with this 2-1, equate with -2. Okay, Cr. So this O4, 4 into -2 plus -2. So this will become Cr -8 is equal to -2. So you have to carry over. So Cr -2 and then plus 8. So I have to reduce this -2 from this 8. So your answer will be Cr plus 6. Okay, so in this CrO4 2- you will get the answer plus 6, and then Cr2O7 2-. So you do that also. Okay, so Cr O2O7 2-. Here also you have to equate with this -2 and 2Cr you write like this plus 7 into -2, that is equal to -2. So 2Cr minus 14 is equal to -2. So you have to carry over this one. 2Cr is equal to -2 plus 14. Okay, and then 2Cr is equal to 12. Cr is equal to 12 by 2. Your answer is 6. So in both the cases you get 6, but here the oxidation state of chromium in CrO4 2- and Cr2O7 2- are not same. So this is wrong. Okay, so this is same only. So the oxidation state is plus 6. I think the correct option is third one only. Okay, so the next one, Cr2 plus, that is D4, is a stronger reducing agent than Fe2 plus D6. So this is also correct. Okay, the incorrect statement. So this only the incorrect statement. And then this is the plus 6 oxidation state. I already explained how to calculate this oxidation number. Okay, and then 112th question. So which of the following is a cationic detergent? So this is in chemistry in everyday life chapter. So this is chemistry in everyday life. So again this is also combined chapter. So we studied this one in surface chemistry also. Surfactants, surface chemistry. Okay, so you have to pick cationic detergent, that is sodium stearate and then cetyl trimethyl ammonium bromide, sodium dodecyl benzene sulfonate and sodium lauryl sulfate. I think the cationic detergent is cetyl trimethyl ammonium bromide is the correct one, because here itself the bromine Br minus is present, and in all other cases the plus cations is present. In this case itself Br minus is present, so this is cationic detergent. I think this is the correct answer. So cationic detergents are quaternary ammonium salts of amines with acetate, chlorides or bromides. Here the bromides are given in your choice. Okay, so they have cations at the soluble ends of the chain. So cations are long chain hydrocarbons having positive charge on N atom. So the example is cetyl trimethyl ammonium bromide. Okay, so this is sodium stearate. So this is not cationic, and this is N plus is present. Okay, so this is cationic detergent. So this is N plus is present in the chain and Br minus is in the anion. And all other examples, so this is SO3 minus Na plus, and then another one here also Na plus is present. So the second option is the correct one. And then 113th question, the freezing point depression constant is given of benzene. The freezing point depression for the solution of molality 0.08 m containing a non-electrolyte solute in benzene is. Okay, so you have to round it off value to 2 decimal places. So this question is from colligative properties. So that is from solutions part. So this is in the 12th standard portion. So here the options are 0.80 K and 0.40 K and 0.60 K and 0.20 K. Okay, so mostly the answers are either in the degree scale or Kelvin scale. Here the answers are in Kelvin. So I think the correct option is 0.40 Kelvin only. Okay, so this is very simple calculation. Del Tf, that is change in the freezing temperature, is equal to Kf. So this is constant into molality. So here, so this Kf is also given, molality value is also given. So you have to just multiply these two things. You get the answer 0.39. So your answer will be 0. So rounded off. So this is 9. So more than 5. So you have to add plus 1 to this. So your answer is 0.40 Kelvin is the correct answer. And then 114. So this is also from periodic table. First one periodic table. So IUPAC name. So mostly the 100 or more than 100. 100 to 118 elements are named according to this IUPAC name. So here name, IUPAC official name is given here, Unnilwunnium, that is Mendelevium, and Unniltrium, that is 1-nilwunnium means 1 means 1, 0, again 1. Okay, so the atomic number of Mendelevium is 101, and 1-niltrium, that is 103, that is Lawrencium, and 1-nilhexium, that is 106, and Zeborgium, and Unnium, that is 111, that is Dermastadium, but this is the, I think, incorrect match. Okay, so this is not 111, the atomic number is not 111 for this particular element. Okay, so the option is, I think, so the D, fourth option is the correct answer. So this is DS, the answer is 110, but in your question paper that is given as 111. So here nillium is the correct one. Okay, 110 means you write that is 11 and nillium is the correct answer. Okay. But here instead of nillium, again here unnium is given. So this one is wrong. Okay, so this is the atomic number for this Dharma stadium. So the mixture which shows positive deviation from Raoult's law. So in Raoult's law, so two deviations are possible. One is positive and another one is negative. So here your question is, so the mixture which shows positive deviation from Raoult's law. Okay, so again this is also from the colligative property, that is solution part only Raoult's law. So benzene plus toluene both are aromatic, and acetone plus chloroform, so one is carbonyl compound, one is haloalkane, and chloroethane and bromoethane both are haloalkane, and ethanol plus acetone. So this is also two are the best solvent, ethanol or absolute alcohol plus acetone. I think this is the mixture which shows the positive deviation of the Raoult's law. So Raoult's law means, Raoult's law states that a solvent's partial vapor pressure in a solution or a mixture is equal or identical to the vapor pressure of the pure solvent. Okay, so multiplied by its mole fraction of the solution. So mathematically Raoult's equation is written like this: P solution is equal to, so this is mole fraction solvent and partial pressure of the solvent. So here P solution is the vapor pressure of the solution and mole fraction of the solvent and vapor pressure of the pure solvent. Okay, so positive deviation from Raoult's law means, so occurs when the vapor pressure of component is greater. So what is expected in Raoult's law? Okay, so in the given example, the ethanol and acetone, so both are all the best solvent. So it's example for the positive deviation from Raoult's law. Okay, so here some examples, other examples also given, that is acetone and carbon disulfide, acetone and benzene, carbon tetrachloride and toluene or chloroform, and then methyl alcohol and water. So this one is given in your question paper, acetone and ethanol and water. So these combinations give positive deviation of the Raoult's law. And then match the following. Again this is also again from periodic table. Again P block. Oxides are given, oxygen family, CO carbon monoxide and barium oxide, and alumina or aluminium oxide. So this is alumina, and then Cl2O7. So you have to match with the correct classification of the acid, that is basic acid, neutral acid, acidic acid and amphoteric acid. Okay, so this is the binary compound. Okay, so this is the options are given here. I think the second option is the correct one. Okay, so oxide and nature, so the CO is the neutral and barium oxide is the basic and alumina is the amphoteric in nature. Okay, Cl2O7. So this is both basic and acidic nature. This is either neither nor, and this is purely acidic and this is purely basic. Okay, so oxides are binary compounds. So in the CO, two compounds, carbon and oxygen, formed by the reaction of oxygen. So in all the options given, so all are having oxygen. is highly reactive in nature. So, they react with metals and non-metals. So, this is the peculiar property to form oxides. So, the classification of oxides is done into neutral, amphoteric, basic and acidic. So, I have to categorize like this. So, acidic oxide is an oxide which when combined with water gives off an acid. Okay, so in your option Cl2O7 is the very good example for this acidic oxide. And then a basic oxide is an oxide which when combined with water gives off a base. That is in your option the BaO is the correct example for that one. And when a substance react chemically, both the base or acid, it termed as an amphoteric. So, Al2O3 alumina is the best example for amphoteric acid. And then this is CO is neutral oxide is one which neither has an acidic character nor the basic character. Okay. So, 117th question, which one of the following has maximum number of atoms? So, this is also from your first chapter, some basic and aspects. Okay, so 1 gram of magnesium, so the atomic number is also given 24, and then oxygen, the atomic number is 16, and then 1 gram of lithium, atomic number is 7, and another one, that is silver, the atomic number is 108. So, this question is also very easy question, and then here the atomic number 7 is very less. Okay, so I think this one is the correct option. So, this is also lateral thinking questions only. So, the gram atomic mass of magnesium is 24. So, 24 gram of magnesium contains, we know this Avogadro number. So, this is Avogadro number. So, I have to calculate 1 gram of magnesium contains atoms. So, 6.022 into 10 to the power of 23, that is Avogadro number, divided by, so this is given in your question paper, that is 24 into 1, that is for 1 gram. So, your answer is 25 into 10 to the power of 21. So, this is for magnesium, and you again calculate for oxygen, that is 16. So, you apply the same method. So, 6.022 into 10 to the power of 23 Avogadro number divided by 16 into 1, you get the answer 37. So, first one is in the range of 50 and second one is in the range of 30 to 40, and then lithium 7. Okay, here. So, 6.022 into 10 to the power of 23, 7 into 1 is equal to 86. So, this is maximum. This is in the range of 80 to 90. And then last one, gram atomic mass of silver, that is 108. Okay, so you apply in the same formula, 6.022 into 10 to the power of 23 divided by 108 into 1. So, this is very less number. So, the option third one is the correct one. And 118th question. So, this is again, so yeah, from carbonyl compounds. So, here aromatic aldehyde and acetophenone is given, okay, carbonyl compounds. So, reaction between benzaldehyde and acetophenone in the presence of dilute NaOH is known as, I think this is aldol condensation or Creion reaction, this one is called, okay. So, this is wrong, Cannizzaro reaction, cross Cannizzaro reaction, cross aldol condensation, everything is wrong. So, the correct answer is this aldol condensation, sorry ma, cross aldol condensation is the correct one, okay. So, this is also wrong. So, this cross aldol condensation is called as Creion-Schmidt reaction, Creion-Schmidt condensation, that is cross aldol condensation. Okay, so this reaction in which the aromatic aldehyde, the question given is benzaldehyde is given in your question paper, benzaldehyde. So this is aromatic aldehyde. So that is benzene ring and CHO. So reacts with aliphatic alkyl ketone in the presence of aqueous alkali. So here in your question paper, the aliphatic alkyl ketone is acetophenone. So in the presence of aqueous alkali, that is NaOH as catalyst. So it is called Claisen-Schmidt condensation reaction or cross-Aldol condensation. And the given reaction, benzaldehyde is an aromatic aldehyde, whereas the acetophenone is ketone group and NaOH is the alkali. I already explained. So when the chemical interaction occurs between these compounds, it leads to the formation of a compound called chalcone. So the product name is chalcone. So this is the structure. Benzaldehyde and acetophenone combines together in the presence of NaOH as catalyst. Okay, get the compound benzylidene acetophenone. So that's common name is chalcone. Okay, so the two rings are fused like this. Get the ketone group. And the next one, a tertiary butyl carbocation is more stable than a secondary butyl carbocation because of the following. This is GOC from GOC, that is basic concepts of the organic chemistry from this 11th standard portion. A tertiary butyl carbocation is more stable than a secondary butyl carbocation because of which of the following? I think the correct option is hyperconjugation is the correct answer. So here other three options also given, that is plus or effect of CH3 groups and minus or effect of the minus that is methyl groups and minus I effect of the methyl group. I think these are all the wrong. Hyperconjugation is the correct one. So this is tertiary carbocation. So all three are attached to the R group. So here 3 R groups are present. Here 2 R groups are present. Here 1 R groups are present. Okay, so the hyperconjugation is the correct answer for this stability of the tertiary carbocation, hyperconjugation. And then stability order of different carbocations. So the tertiary carbocation is more stable compared to that of the secondary, primary and methyl. 120th question. Which of the following is not correct about carbon monoxide? Again, this is also in P block. 14th group. And then carbon family. So this is from carbon family. It reduces oxygen carrying ability of blood. Okay, so which one of the following is not correct? So you understand the question. So it reduces oxygen carrying ability of blood. I think this is correct. And the carboxyhemoglobin is less stable than oxyhemoglobin. So this is the incorrect answer. Okay, so this is carboxyhemoglobin is more stable compared to the oxyhemoglobin. But here the option given here is less stable. So this is the incorrect statement. And then other two options produced due to incomplete combustion. So this is also correct. So that only carbon monoxide is the air pollutant and poisonous gas also. And then it forms carboxyhemoglobin. So everything is correct. So the wrong answer is the carboxyhemoglobin is less stable than oxyhemoglobin. Carboxyhemoglobin, so this is a symbol, hemoglobin combined with this carbonyl group or carboxy group or HbCO. So you write either like this, COHB or HbCO is a stable complex of carbon monoxide and hemoglobin that forms in red blood cells upon contact with carbon monoxide. Okay, so this is impure blood and then toxic also. Okay, so this is carbon monoxide and this is hemoglobin. Hemoglobin combines with carboxy, that is the CO group, to form carboxyhemoglobin. So this is very stable compound, but in the question paper, so this is less stable. Okay, so this bit leads to the anorexia, anoxemia and then suffocation, everything occur. So due to the less concentration of oxygen. Okay, because the oxygen is substituted, in the place of oxygen carbon monoxide is present. And then which of the following is a basic amino acid? Again this is also from the biomolecules chapter. So the first question is also from the biomolecules. So that is from carbohydrates and this is from biomolecules, this is from proteins. So the amino acids classification is of various types, and the main type is the essential, semi-essential and the non-essential. But here the question type is based on the groups, R group present in the amino acids. So the basic form of amino acid is carbon and then one amino group and one COOH group. Okay, one is H and another one is R group. So due to the presence of the R group, so the 20 amino acids can be classified into so many types. So suppose the amino acid group is amino group or basic group, means that is called as basic amino acid. So this is again the R group is acidic group, means that is acidic amino acid. For example, glutamic acid, aspartic acid and then everything. And then R group is aromatic, means aromatic amino acid, for example tyrosine and then phenylalanine. So this R group is heterocyclic, means that is tryptophan, everything. But here your question is basic amino acid. Here some options are given here. So alanine, tyrosine, lysine and serine. I think the lysine is the correct option. Okay, so totally out of 20 amino acids, so 3 amino acids are considered as the basic amino acid. So that is, the first amino acid is lysine, another one is arginine and the next one is histidine. So here the option lysine is given. So lysine is the basic amino acid. Okay, so this is in the place of R. Another one amino group is present. So due to the presence of this one, so this is called as basic amino acid. Okay, so this is the structure for lysine. So this is amino acid. Okay, so hydrogen, one COO group and then here NH2 group. So that is, this is due to the presence of this one. So this is basic. Okay, already this is amino group and this is carboxyl group. So this is amino group and this is carboxyl group. And this group collectively called R group. So in the R group, extra one amino group is present. So this is due to the presence of this one NH2. So this amino acid is called the basic amino acid. So this is basic amino acid. So basic amino acids, there are 3 amino acids that have basic side chains at neutral pH. So this is more important. So they are arginine, I already said. that is lysine and histidine. So in your question paper, so this lysine is given, okay. And then 122nd question, urea reacts with water. So urea is easily dissolved in water, so that only urea is considered as the major excretory product of animals, okay, major excretory product, because it is easily dissolved in water. So this is non-toxic. So two toxic substance, that is carbon dioxide and amine. So the carbon dioxide is the end product of the carbohydrates and ammonia is the end product of the proteins combined together in liver. Urea cycle, during urea cycle the urea is formed. So the toxic substance will combine to form the non-toxic substance. So the formation of urea is the detoxification process, okay, detoxification process. So to form A, I think so the A will be ammonia, NH3, which will decompose to form B. B when passed through Cu2 plus aqueous, that is copper, cuprous. So Cu3 plus mean cupric. So this one is cuprous. A deep blue color solution is formed. What is the formula of this C? Okay, I think this one is the coordination complex. So here the ligand is NH3 and then this is the metal atom. The cuprous is metal, I think. So what are the options given here? CuNH3 4 times 2 plus, CuOH twice and CuCO3, CuOH twice and CuSO4. But I think this is the correct answer, the coordination complex. Okay, so this is ligand and this is central metal atom, Cu. Yes, so this is correct answer. So this is also again combined chapter in P block elements, 15th group of elements, that is ammonia, that is nitrogen, and then Cu, that is D block, and this is the coordination complex. So ammonia acts as the Lewis base here, so that only the B product is ammonia. So due to the presence of the lone pair of electrons, we already discussed in the previous questions, okay, on the nitrogen atom, therefore it can form coordinate bond, so that only the coordination complex is formed, okay. So the major difference between coordinate bond and covalent bond, so in both the cases sharing of electron, so only one sharing of electron means that is called as covalent bond. So a pair of electron sharing means coordinate bond, okay. So with the electron deficient molecules or a number of transition metal cations, that is D block elements. So ammonia reacts with a solution of Cu2 plus to form a deep blue colored complex. So the reaction for the above complex can be written as follow. So this is Cu2 plus reacts with ammonia to form this coordination complex. So this is deep blue in color. Mostly coordination complex are colored compounds. So this property of ammonia to form complex compounds is useful in detection of metal ions. So this is one of the major use of this property of ammonia. And then 123rd question. So here this is also from gaseous state. So 11th standard portion. So a mixture of nitrogen. So this is diatomic and argon. So this is noble gas. So this is the 15th group of P block and this is the 18th group of P block. In a cylinder contains 7 gram of nitrogen and 8 gram of argon. Okay, so in a single cylinder contains both the mixture of gas, that is 7 gram and 8 gram. So the total is 15 gram. If the total pressure of the mixture of these gases in the cylinder is 27 bar, so here this is masses I am writing here, but here the total pressure is 27 bar. So the partial pressure of N2, okay. So you have to calculate the partial pressure of N2. So I calculate the partial pressure of argon also, but your question is the partial pressure of nitrogen. So use atomic masses in gram per mole. Nitrogen is 14 and argon is 40, okay. So here 12 bar, 15 bar, 18 bar and 9 bar is given. I think the B option 15 bar is the correct one. Okay, so this is method to calculate to find the number of moles of each gases. That is, mole is equal to mass per molecular mass. So here mass is given 7 and molecular mass. So in your question paper nitrogen is given. So this is diatomic N2. So you have to multiply 14 into 2, so that 28. So most of the students substitute the 14 as such. That is wrong. Okay, so you have to multiply into 2 because the nitrogen is in the diatomic form. And then mole of argon is in the monoatomic. So you just substitute 40. So here 0.25 mole and this is 0.2 mole. So the total number of mole in the mixture is, so this is for diatomic nitrogen and this is for argon. You have to sum up these two things. You get the answer 0.45 mole. And then Px is equal to P total Nx divided by N total. Here Px is nothing but partial pressure of gas and P total is nothing but total pressure of all gases, and Nx equal to number of moles of gas. So N total is equal to number of moles of all gases. Here two gases are given. So partial pressure of nitrogen, this only your question. So that is Pn2. So this is 27 into 0.25 divided by 0.45. So this is total moles. So this is moles of nitrogen and this is 27 is given in your question paper. Okay, so you have to divide 0.25 from 0.45 and then so the remaining answer is multiplied with this 27, you get the answer. Okay, so 27, so that division product is 0.55. Okay, so you get the answer 15 bar. So 15 is the correct answer. So if argon means the partial pressure of argon is 12 Pa. Okay, so this is also 12 bar. And identify the correct statement from the following. So blister copper has blistered appearance due to evolution of the CO2. And then you have to identify the correct statement. I think this statement is wrong. So this is due to the evolution of sulfur dioxide. But here carbon dioxide is given. So this is wrong. So vapor phase refining is carried out by nickel by von Orkel method. I think this is Monk method. So this is also wrong. And third one, pig ion can be molded into a variety of shape. I think this one is correct. And wrought ion is impure ion with 4% carbon. I think this is also wrong. Okay, so this is cast ion, I think. So here wrought ion is given. So the correct option is, third one is the correct one. Okay, so the iron obtained from blast furnace contains 4% carbon and many impurities in the smaller amounts. So this is known as pig ion. But in your question paper, so that is given as a wrought ion. Okay, so it can be molded into variety of shapes. And then cast ion is different from pig ion and is made by melting pig ion with scrap ion and coke using hot air blast. So it has slightly lower carbon compound, that is 3%, and is extremely hard and brittle. So it cannot be molded like pig ion. Okay, cast ion cannot be molded. And then vapor phase refining is carried out for nickel by Mons process. But in your question paper, that is Orkel method is given. So that is wrong. Mons process is correct. And then next one, blister copper has blistered appearance due to the evolution of SO2 only. But in the question paper, CO2 is given. So that option is also wrong. Okay, and then 125th question. Again, this is from sucrose. Okay, and but this question is from chemical equilibrium. That is our 11th standard portion. So sucrose plus water. Okay, so hydrolysis of sucrose. So this process is hydrolysis of sucrose. So to give monomeric units, 2 monomeric units. So this is the first question, that is alpha D glucose and beta D fructose. So that's the answer for the first question. If the equilibrium constant is given 2 into 10 to the power of 13 at 300 Kelvin. So the value of del or G naught is equal to, okay, so that is equal, the value is given minus 7.64 into 10 to the power of 4 joule per mole at the temperature. So here this one is given. Okay, so you have to calculate. So the option, so this sum is somewhat in reverse manner, I think. So the correct option is the last one, 8.314 J per mole per Kelvin into 300K into Ln 4 into 10 to the power of minus 3. Okay, so that's the answer. So this is your formula, del G naught is equal to minus RT Ln Kc. So I have to substitute the fourth option here. So minus 8.314 joule per mole per Kelvin into 300 Kelvin into Ln 2 into 10 to the power of 13. So you have to multiply all those things. You get the answer minus 7.64 into 10 to the power of 4. Okay, so this is 10 to the power of 4 joule per mole. And then 126th question. Identify a molecule which does not exist. So this is also you studied in your 12th standard. So the bond order is 0. So one explanation is bond order is equal to 0. So it does not exist. And then helium is in the 18th group of P block. So in 18th group element start from helium and ends with oganesson. All are in monoatomic form only, not in diatomic. Because this is more stable. So it obeys the octet rule. But in this case helium, so the helium atomic number is equal to 2. Okay, so this is nucleus and this is first K orbit. So it has 2 electrons. So this is completely filled K shell. Okay, completely filled. Completely filled K shell. So this cannot form. Okay, so this does not exist. So again lithium 2 and C2 and O2, these 3 things are possible and this is not possible because the bond order is 0. Okay, so this one is, so this is very easy question. Okay, and this is also again from the chemical bonding and as well as the periodic table combination. Okay, so this is the bond order is 0. So this helium 2 molecular form is not exist. So it always exists in helium atom form only. So this is monoatomic. But in your question, so this is in diatomic. So this is not possible. Okay. And then 127th question, an increase in the concentration of the reactants of a reaction leads to change in. So here the heat of reaction is wrong, threshold energy is also wrong, but you have to increase the concentration, the collision frequency is more, okay, leads to change in. So increase, the change is increase here. So this one is the correct answer, I think. Activation energy is also wrong. So collision frequency is the correct one. So increase in the concentration of the reactant leads to change in collision frequency. Okay, so mostly if the concentration of one or more reactants is increased, so the reaction and the rate of reaction is also increases. Okay, so this happens because a higher concentration of a reactant leads to more collisions of that reactant within a particular time of period. I will explain with the diagram. Okay, here lower concentration, few collisions only occur, but here so more collision. So this is also collision. So collision, collision. So more collision will possible in more concentration. Okay, in higher concentration, more collisions, but here only few collisions are occur here. Few collisions at lower concentration and more collisions at higher concentration. Okay. And then 128th question. Which of the following alkane cannot be made in good yield of Woods reaction? Okay, so the Woods reaction is the important reaction for the production of saturated hydrocarbon alkane. Saturated hydrocarbon alkane. So already, so two questions from alkene and this question is from alkane. So this year paper, so most of the questions from the hydrocarbon chapter also, 11th one, hydrocarbon. So the questions are from both aliphatic and aromatic hydrocarbons. I think here, so the N-heptane is the wrong. So this is the correct one. So which cannot be prepared effectively by the Woods reaction is the correct one because this is symmetrical. So this is symmetrical alkane. Heptanes means carbon 7. Okay, consider this one. So take this CH2. So here CH3, 3 carbon atom and 3 carbon atom. So this is symmetrical. So this is not more effective to synthesize by using this Woods reaction. And then next one, which of the following amine will give carbylamine test? So this is from amines are the organic compounds containing nitrogen group. Okay, here NHCH3 and NCH3 2. I think so. This is primary amine only give this answer. Carbylamine test positive. Carbylamine test. And then secondary and tertiary. So no answer to this. So the offensive smell of product is formed here. Okay, so this is again, I think this is the primary amine. So this only gives that carbylamine test. Okay, so the fourth option is the correct one. So carbylamine reaction is given by primary amines only. So this is more important. So it's not given by secondary or tertiary amines. So all other things are belong to that secondary or tertiary amines. Okay, so this is one example. So ethylamine. So this is primary amine. So here chloroform and potassium hydroxide is, it reacts with these two chemicals. So this is carbylamine test. We take these two reagents and you have to heat. One gas is evolved from this reaction. So that is having offensive smell. Okay, so this is, but here the diethylamine or triethylamine does not react with this chloroform and potassium hydroxide. There is no gases formed, no offensive gas. And then 130th question, on electrolysis of dilute sulfuric acid using platinum electrode. Okay, so this is also from electrochemistry chapter, electrochemistry. So the oxygen gas, hydrogen sulfide gas, sulfur dioxide gas and hydrogen gas. I think that oxygen gas is the correct one at anode. So here both gas are released, oxygen gas and as well as hydrogen gas. Hydrogen gas is liberated at cathode end. This only anode. Okay. So when dilute sulfuric acid in H2SO4 is led for electrolysis with platinum electrodes, two different gases are evolved at both anode and cathode. I already explained. So hydrogen gas is liberated at cathode and the oxygen gas is liberated at anode. So this is your question. So oxygen is the correct answer. This is the diagram. Okay. So what is the change in oxidation number of carbons in the following reaction? So this is a redox reaction. Okay, here, so you need to calculate the oxidation number for carbon in methane and carbon in tetrachloride. I think this is +1 condition. So +4. So go to that side -4. I think the oxidation state -4. Here ClO4 minus, go to that side. So -4 is equal to +4. I think so. The option -4 to +4 is the correct one. Okay, in CH4 methane, the oxidation number of hydrogen is +1. So C +4 is equal to 0. So you have to transpose this +4 from left hand side to right hand side. So the oxidation number of carbon is equal to -4. Let the oxidation state of carbon be X. The oxidation state of chlorine is -1. So the total charge on compound is 0. Okay, CCl4 is equal to 0. So the formula X plus 4 minus 1 is equal to 0. 4 into -1 -4. That -4 transpose from left hand side to right hand side. We get the answer X is equal to +4. And then 132nd question. Anisole on cleavage, which gives with hydrogen iodide, gives anisole on cleavage with hydrogen iodide gives what type of? I think so this is not wrong because the iodine is attached in the aromatic compound. So this is wrong. I think here ethyl iodide is also not formed. I think methyl iodide is formed. So this is also wrong. And then this is iodide. Again this is wrong. So this one is the correct answer. Okay. So phenol plus this methyl iodide is formed. I think that one is in yellow color, I think. So already 2018 paper also this type of questions already asked. So measuring zeta potential is useful in determining which property of colloidal solution. Okay, so solubility, stability of the colloidal particles, size of the colloidal particles and viscosity. So this question is from surface chemistry. Already that cationic detergent is also from surface chemistry lesson. This question is also from surface chemistry. That is zeta potential, I think. So the stability of the colloidal particles. Okay, so the measuring of zeta potential is useful in determining the stability of the colloidal particles. So that one is the correct one. Okay, so typically the higher the zeta potential, so the more stable the colloid. So that's the answer. And then 134th question. So paper chromatography is an example of partition chromatography, thin layer chromatography, column chromatography and adsorption chromatography. So this paper chromatography is an example of partition. So these three are the other type. So this is called as partition chromatography only. So this is very useful in the separation of things. So in partition chromatography, the substance is distributed between two liquids. One is stationary liquid, which is held in the fiber of the paper. So that only, so this partition chromatography is in the Paper chromatography is the best example for partition chromatography. Okay. So this is the diagrammatic representation. So this is paper, and then you get different types of colors. So you have to separate the components by using this paper chromatography. I think this is the last question of this chemistry. Match the following and identify the correct option. So here also carbon monoxide and hydrogen. I think so this is the synthesis gas. And then temporary hardness. So this is due to the presence of this magnesium and calcium bicarbonate ions. And then B2H6. So this is electron deficient hydride, and then H2O2. So this is a non-planar structure. Okay. So this is the options 3, 2, 1, 4 and 3, 4, 2, 1. I think the last option is the correct one. Okay. So COG and H2 synthesis gas, and temporary hardness of water is due to magnesium bicarbonate and calcium bicarbonate, and B2 diborane. So this is an electron deficient hydride, and this is non-planar structure. I will explain the electron deficient also. Diborane, it contains only 12 electrons. So this compound contains less number of electrons to form all two centered 2 electron bonds. So it's called as electron deficient compound. So this is the diborane structure. Okay, so this is electron deficient compound, and this is hydrogen peroxide structure. Okay, so I think I completed. Thank you.